So I hope I'm live right now. Just someone, whoever is watching this video right now, just give me a confirmation whether I'm live or not. Okay. So if I get the confirmation, I'll be like, yeah, I can start with the video. Okay. Just give me a confirmation. Okay. Let me check it also. Okay. Yeah, from my side, it's showing that I'm live. Okay. Sorry, let me mute it. So I'll just wait for a few seconds, okay, till everyone joins. I'll just wait. It's two watching right now. Okay, I'll just wait for a few minutes. Okay, it's 9:33 right now. Chat, can you tell me whether I'm lagging or not? Chat, just tell me whether I'm lagging or not. Okay. Just tell me if I'm lagging. So let me just do the settings a little bit. Okay. Just wait till I do the settings. Okay. This is perfect. Okay. This is just perfect. So just chat, just tell me if I'm completely audible and you guys can hear me or not. Okay, just give a confirmation, just give a thumbs up. So I'll be starting with the video in that case. Okay. Since it's two watching right now, so I'm just assuming that apart from me, one other person is also watching this right now. So just tell me if you can hear me and if you can see me or not. Okay. I'm waiting. So let me do one thing. For now, I'll just add this paint thing, okay, in my background, and keep stop the device sharing. I think I forgot how to do that. I really forgot how to do that. Okay, yeah. So basically, yeah, I can do what I can just add a window capture. Yeah, window capture. I'll just okay. No, I'll just capture the paint. Okay. So this works perfectly fine, I guess. So I just keep the window capture below this so that you guys can see me. Okay. So I hope this is like completely visible for you guys. Just give me a thumbs up so that I can start with the video. Okay. Otherwise it's like I can't start with the video if I'm not sure whether you guys have joined or not. Just give me a thumbs up, chat. I think it will be better if I wait till 9:40 and then after that I will start with the video. Okay, till 9:40 I will wait. Anyways, whoever is over here right now, I will just ask you guys, like, how was the contest for you guys? Like, was it good? I think the first two questions were easy, and I have think that maybe the last two questions were difficult. The second last question was kind of easy, like it was kind of medium problem, you may say, but the last question, it was kind of tricky. I mean, not tricky. It was difficult. Okay, it was difficult. The chat, it's like I'm not getting much response at this moment. I'm waiting for you guys to respond so that I can start with the video. Okay. So anyways, let me start with the video. Okay, I think I waited for too long. I'll just start with the video. Okay, so okay, just 1 second, I just connect myself, just check the connection once. After that I will start with the video. Is it like very less people have joined the contest, I guess, right? Right? I don't think much people have joined the my like waiting too long time. I promised you that we're starting from 9:40. Okay, I'll start from 9:40. Namaste, namaste, guys. Namaste, Soumya. Okay, so let me start with the video. Okay, just let me start with the video. So the last, okay, I got disconnected from my, like the camera got disconnected, right? Oh. Yeah, I just noticed it. I think now camera is fixed. I think now the camera is fixed, right, Soumya? Okay, so let me do one thing. I'll just put this down. Visible, yeah, I get it. And I'll just keep this on top of this and keep the video capture. The video capture will be on. Rather, I'll just keep the window capture off. Okay. The video capture will be above that. Okay. So I hope, yeah, visible. Okay. So let's go on with the first problem. Okay. So let's move on to the first problem. Okay. So this is my video. So if like this thing, okay. So this is a very important approach. I will be explaining you what is Hungarian algorithm, which is an alternative for the third question. Okay. So first of all, I'll just go on with the first question, that is, check if two chessboard squares have the same color or not. Okay, so you're given two coordinates, coordinate 1 and coordinate 2, and what you have to do is you have to basically check. So contest missed. Okay, I think today's contest was kind of difficult. I don't know why, because I couldn't solve the last two questions without watching the editorial, right? I was just now watching the editorial, and I think like I went very close to the solution. Okay, I'll just show you the solution that I did. After that, I'll just give you the solution of what exactly to offer. So okay, so was I was explaining this question. Okay, so there are two coordinates, coordinate 1 and coordinate 2, represent the coordinates on the 18 to 8 chessboard. Okay, so if you have like, if you're a good chess fan, so you have already played chessboard, and it is like any black square, okay, any black square, the next square to that it is white, and any white square, the next square to it is black. So this is a very important point that you have to keep in mind. Okay, next to black is white, and next to white is black. So if you are having a, let's say, if you can go straight in straight lines, okay, let's say you don't have the ability to go diagonally, so in that case, I'll have to watch your solutions and your way of explanation, brother. Keep it up. Thanks, man. So basically what happens is like, since we know that if, let's say we have a chessboard and we sorry, let me draw it better. So let's say we have a chessboard, and for now I'm going to consider the 3 into 3. Okay, now if I am at this position and I consider that I can take one step, that is using the rook. Okay, but the rook is it is a combination of rook and the rook and the king. Okay, so basically what happens is you can use the, okay, so just tolerate me for a few minutes so that I'll just make this pin. Okay, yeah, so it's just out of fix. Okay, so guys, just let me know if I'm lagging anyhow. Okay, just give me like, write in the comment section if I'm lagging. Okay, so let's go get in the explanation again. So basically if you are having at this position, so you are going to move like a rook, but the number of steps that you can take is basically that of a king. So that is, you can take one step either either up, down, left, right or left. Okay, and if you do that, what you do is you either go from black to white or you go from white to black. Clear? So you are getting, like, if you're performing steps like this, left, up, right and down, so you know one thing, that this you're just switching the positions. So after two operations you get back to the same color, right? After two operations you get back to the same color. Now let's say we have a point over here and we have a point over here. So what is the shortest distance? It is this, right? But let's say we can only go from right, left, up and down. So in that case, the shortest distance will be like go from here to here and then go from here to here, right? And doing this, you can find the number of steps that is required for this. Okay, so how you're going to find it? So let's say this is at a position of x2 and y2. Okay, and this is at a position of x1 and y1. Okay, so basically x2 minus, since we know that over here we are going to just consider the box, the square. So if I subtract x2 minus x1 and y2 minus y1 and take its absolute values, okay, take its absolute values, because it may also happen that this was over here, right? So take its absolute value so that it doesn't give us a negative approach, and you just add them. So you know how many steps you have to perform to reach from one specific square to the other square, right? Okay, I think someone commented, a bit laggy for me but manageable. Is it like kind of too laggy? Okay, just give me a second. Okay, I'll just fix it in that case if it's too laggy. Anyways, from my end, it's showing that there is no lag. So maybe it was laggy for a few seconds, I guess, right, Soumya? I guess it was lagging for just a few seconds. Because like it is showing me that the drop frames are almost 3%. Okay, so it's like not much of a lag, I'm just assuming, and it's going perfectly with 4246 kbps. Yeah, it's cool now. Yeah, I get it. So let's get in the video. So basically, what happens is you're going to count the steps, and based on that, you can find which color it is going to have. Now you can see one thing, that if the number of steps, it means that the color has exchanged. But if the number of steps is even, in that case you can say that the color is same. Okay, because for one step the color changes, for the next step the color goes back to the same thing, again it changes, again it goes back to the same thing. So for even number of steps it remains the same color, and for odd number of steps it changes color. Clear? I think now I got a lag again. I think now it's okay again, back. Okay, so is this clear? Is this clear for you guys? Just let me know if this is clear. Okay, so the lag is not because of my internet connection, I guess. The lag is because of my device connectivity. Okay, so what I'll do is I'll just keep this thing off. Okay, I'll just keep this thing off because it is the reason why I'm getting the lag. Too many background apps running. So I'll just read your questions, read your comment section from here. Okay, so just be kind of interactive so that I don't have to watch the video. Okay, just if you can't hear me or if there's a lag, just be straightforward enough and just tell me. Okay, so that is clear, right? So I'll just go through the code once. Okay, the code is very simple. This answer is the number of steps, and I'm just finding the absolute value of these. Okay, and I'm just checking whether it's even or not. So what happens if it is even, you're going to return true, and if it's odd, you're going to return false. So this is like if answer mode 2, no, if not answer mode 2. Okay, so I hope this is clear. The code is clear, I guess. Okay, let me keep this off. Chat GPT, I'll explain you something from the Chat GPT. So I've just kept it on. Okay, so I hope this is clear, right? I'm just assuming that this is clear, so that I'll go to the second question. So let's go to the second question. I'll just put this off because too many background stuff. Okay. So the next question was kth nearest obstacle queries. Okay. Now what happens over here? It is that you're given an infinite 2D plane, and you're given a positive integer k. You're also given a 2D array called queries, and in this queries you're going to place an obstacle in the plane at x comma y, and you have to find the kth nearest obstacle after every queries that you put in it. Okay, so now after every queries, so we can say one thing, that till there are not as enough as k insertions, okay, till that we can say that it is going to be -1, right? So see, for 1, whenever there is one insertion, there was -1 because k is 2. So you can't operate this until and unless you reach the second element. I mean the second position. Okay, and for this you can see that k is equal to 1, so it's none of an issue. You can just start with the first element. Okay, so that is what it demands. Now over here you would be needing a priority queue. Okay, guys, just be kind of interactive. I'll just check. I don't know whether this YouTube live control panel, how it works. Okay, basically I think this will also create a lag on my thing. Okay, so I'm just clearing this out. Yeah, okay. So what happens is, like, so let me go into the explanation. real quick. So I'll just delete this and just explain you. Okay, so let's say you are having, okay, so I'll just get a rough through of the question. Question 1 I did even black, odd black, rest white. Yeah, that is also a good thing. Okay, that is also a good thing, but what I feel is like even, odd, like obviously if you're a chess player, so if I'm like blindfolded, then also I can do it. Okay, but why I did question 1 in that way is because of the number of lines of code. Okay, the lines of code will be lesser in that, because for every even you have to check, for odd you have to check, and I think both of them will be of the same line of code. But anyways, I thought my approach, like at that moment I came up with my approach. So there are obviously many approaches you can come up with. So it's not about okay. So let's get into this question. Okay. So what we were doing was we were building an obstruction. Okay, and remember one thing, over here the distance is calculated. Okay, over here the distance is calculated by the formula of mod x plus mod y. So after every insertion that you do, okay, after every insertion that you do, you have to find, like you have to insert, what you have to insert, you have to insert this value, okay, mod x plus mod y, this value you have to insert in it. And after you have inserted it, you can do what, you can just sort it down, and you can find the kth nearest element, which is the brute force algorithm that you may come up with. But for this question, you can't go for the brute force algorithm. And another approach is the priority queue. But I think if you're using the priority queue, so you have to pop k times in order to get that thing. So just using the brute force of the priority queue won't work also. Okay, clear? So, I got your approach. Heap. We can say it is a heap. Obviously, priority queue is a heap. Okay, priority queue is a heap, technically. So what you're going to do is, you're going to optimize the priority queue using just till size of k. Okay, till you reach the size of k, you have to just keep on inserting the elements in the priority queue. Okay, till the size of k. Now, once you have inserted for k elements, now you know one thing, that you are going to insert the next element into this only if the maximum element is greater than this element. Okay, if the maximum element is greater than this element, then only it gets inside this. Okay, otherwise we can insert it. It is not of a much big deal to insert it. But if we insert it, so it will be inserted after this, right? And which will not be of much information for us. Okay, because we just need to find the first k elements and the kth nearest element. Okay, so basically if you are going to have a priority queue of size k, and for the last position, what you can do is, for the last position you can find whatever the value is and append it to the answer. Okay, and append it to the answer, then only it works, right? So for every element, for every queries that you are going to come across, what you have to do is, you have to basically check whether that query is going to generate a distance lesser than the maximum element in the queue. If it is so, what you can do is, you can remove the maximum element and insert that new element into the priority queue. And if it is not so, you can just ignore it. In that, if you do that, what happens basically is that the whole array, I mean the whole priority queue, okay, the whole priority queue is always going to have just k elements. So over here, if you look at the insertion and deletion, now let's get into the, like, I'll just give you a approach. Like, if you look carefully, the value of k was of 10 to the power 5 and the value of queries were of 2 into 10 to the power 5. Now, if we can, in spite of using a priority queue of size 2 into 10 to the power 5, if we can use a priority queue of 10 to the power 5, it is obviously going to be reduce the time limit, right? Now, since it is reducing the time limit, so it's a better approach. Clear? Yeah, size. Yeah, limiting to size for log k. What it happens basically is that, okay, my PC is low of charge. Let me put it into charge. Okay. Okay, so now it's charging. So what happens basically is that if you're limiting it, so it becomes k log k. Okay. N log k. Okay. And log k is like it's best because for n insertions you perform either insertion or deletion, and insertion or deletion, the maximum complexity that it will take is, the worst case scenario, it is log k. So basically you're using the whole thing and you can do it in n log k. Okay, so that is a better approach. So people who thought that you can do it using this approach of using n is this 2 into this thing. Okay, this thing is the case where you have to understand that you can't use n log n, you have to use n log k. Okay, you have to use n log k. So that's it for k. That's it for 2 numbers, the second problem. So I'll just go with the code a little bit. So what I'm doing is I'm initially taking a priority queue and I'm just taking the size of the queries. Okay, this was not much needed, but I did it because I need to initialize answer with n and -1, as I told you, -1, because till I am not getting all the k elements, I can just simply write -1 because I am not getting the kth nearest element, right? So now we're just pushing till the first k elements, that is minimum of n comma k. We're just pushing the absolute values of these, we are just pushing into it. Okay, and if k is lesser than equal to n, now this condition is because let's say we have a n and that n is well less than k. In that case, what happens is, no matter how many elements that you have put into the array, put in the priority queue, all the elements has to be -1 because the priority queue doesn't have the size of k at that moment. Okay, so that is why we are using k less than equal to n, and then only we are going to make answer of k-1 as top. And for the remaining insertions, what first I am calculating the distance. Okay, and if I'm checking that if pq is empty or if pq of top is greater than distance, as I told you, okay, then only we are going to push. Now if we are pushing it, we are pushing the distance and then we are popping it. Okay, you can do the reverse also. You can just pop pop first then push. That also makes sense. That also won't be a big deal. Okay, so basically both of them works. So now after that you're going to assign answer of I to pq of top and return answer. So I hope this is clear with you guys, right? Is this clear? Because I can't see the number of people who are watching my video right now. Okay. PQ of top and return. Okay, so from my end, it's showing that 7 people are watching this video right now. So just give a whoever is watching the video, my request, just like the video, just subscribe my channel if you're new, and just leave out a comment and just share it with your friends, because at this moment I'm having a kind of low reach, so it will be very helpful. Okay, if you do that. Okay, समझ गया. चलो next question पे जाते हैं, ठीक है? C question, which is, okay, so I'll just delete this. Okay. Now we are going to the C. You don't need to check this because I think I deleted my submission. Okay, now Control Z is also not working, so I deleted my submission that got it. Okay, and I think this is my second account, so I won't be able to see that. Okay, so I'll just give you the code later on. I'll just explain you. Okay, so for the third question, select cells in grid with maximum score. Okay, I think this was one of the most awaited questions that most of you must be watching this video for. Most of you who are watching this video, I think you guys are watching this video for this question only, for this and the last question. So what happens is basically you're given a 2D matrix grid consisting of positive integers, and you have to select what? You have to select one or more cells, but all these cells that you are going to select, you are going to select only one cell, at most one cell from every row, and the values in set of selected cells are unique. Okay, so over here I don't have the like perfect code. Okay, I don't have the perfect code for that, but I'll just give you the time limit exceeded code, which went on till 514 cases. I mean 513 cases. So this approach first I will let you know. Okay, this thing I'll just first give you an overview, and then I'll just give you the overview of how to get the solution of this question. Okay. So let's get into the. Okay, so what you have to do is return the maximum score you can achieve. Okay, so I hope I won't explain the question much. Okay, I won't explain the question much. I'll just get in the explanation directly. Okay, so let's say for C, you have a grid. You have a grid like this. Okay. Now it was given that the size of the grid was, the maximum size can be 10 into 10. Okay, nothing more than that. So from that approach, we can see one thing, that if it was 9 into 9, or even 10 into 9, or even 9 into 10, in that case, a recursive approach will be perfect. Okay, which is the approach that I'm going to tell you first, so that you get the basic idea that how you need to solve that problem. And after that, I'm going to give you a more greedy approach, but there won't be any DP approach. As far as I think, there won't be any DP approach, because for DP, the memory limit will be exceeded. Okay, but if you are using DP. So what you can do is, basically, let's say you're having this. So for every specific element, for this element, you're going to have a map, a frequency map. Okay, the map which is a frequency map. Here, just let me check. So no comments. Okay, so for the frequency map, you're going to insert it, and then you're going to go to the next row and check for all the elements which are not present in the frequency map. And for the specific element, what you can do is you can add it to the map, add it to the frequency map, and then let it go to the next row. Okay, then let it go. So for every element, you are going to put it to the map, and then let it go to the next row. Now there may happen that for a whole row, okay, for a whole row, all the elements have occurred in the previous row. Okay, all the elements have occurred in the previous row. I mean, like you can't perform any operations on that row. Okay, so in that case, you have to do what? You have to just skip without even adding. You have to just skip to the next row. Okay. So by using that, what you can do is you can find the sum of all possible operations. Okay, I'm lagging. Also won't be a big deal. Okay, so basically both of them work. You can find the sum of all possible operations. Lagging. Just tell me if I'm lagging right now or not. Okay, I think I fixed it. I fixed it. Just tell me if I'm lagging till now. I'm just assuming that I'm not. Whoever is watching this, Soumya or whoever is watching this, okay, just tell me. Why not DP? Okay, I'll just explain you why not DP. Okay. So I'm just assuming that. Okay, so first let me explain you this thing. Okay, yeah, you can use DP. I guess I'll just explain you. Okay, I'll just explain you. Just wait. So what happens is, whenever you're getting that recursive thing, so you can get the all the permutations, and whichever is the maximum, you can return it. So first let me show you the code for this. So if you look at the code for this, what I am basically doing is I'm taking for every element, okay, from 0 to m, I'm taking a frequency. Instead of using map, I'm using a vector, okay, so that it's better. I like it works the same, okay. Since the values of frequency is, I mean the values of nums_i is not that great, so you can go on with vector instead of using map. So I'm just adding the frequency of that element and putting and recursively calling this function called fun, and just putting the value of that grid. So this is basically the sum, the current sum, okay, because whichever element you're starting from is going to be the current sum, and then you're going to return the frequency array, I mean the frequency map, or as you may call it, then the grid, that is the whole 2D matrix, and then this is the current position that you have to check. This is the value of n, this is the value of m, and then I'm going to retrieve that frequency, retrieve that element from the frequency array. Okay, now answer is actually 0, because you can, the best approach, like if everything, if nothing works, so it's always 0, okay, because all the elements are greater than 0, so it's always a better approach. So if current and last are equal, so last is basically n, okay, so if both are equal, you can just maximize answer and return. And for the remaining part, what you can do is you can traverse throughout the whole elements, all the elements in the in that present row, and you have to check if the frequency, okay, if the frequency of an element has occurred earlier, so you can continue because you can't use that. But if it has not occurred, in that case you are going to do the same thing, adding it to the frequency, then sum plus this, the remaining are going to be same, and current plus 1, and then you remove that element, okay, and then you just recursively use this thing. This is the condition where you are going to skip any insertions, okay. It may happen that you don't have any insertions at that place, so that also works. So this is what basically the recursive approach tells us, but this is going to give you a time limit TLE error, okay. So now let me first, I'll just clarify you first, okay. I'll just tell you why DP can't be used, why I feel that DP can't be used, but there may be some approaches of using DP. So what DP does is basically, whenever you're using DP, you have to find all the permutations, okay. You have to find all the permutations. So whenever you're finding all the permutations, so basically for this recursive approach, you have to find all the permutation which is maximized at 10 to the power 10, and anything of this range, even we avoid 10 to the power 9, right? Even we avoid this 10 to the power 9. If it's 10 to the power 8, then only we go with the code and tell that it won't be a time limit exceeded. But this is the maximum limit that we can go with, okay? And we try to avoid these. So in this case, what happens is, if you're using a DP, so let's say for one position, okay, for one position you are having like a DP, so you can find all the elements which are not present over here, right? So till the first row it is okay, DP works perfectly fine, but in the second row also it works perfectly fine. But in the third row, let's say for this specific element, this element and this element are not the same. So your basic approach will be take this DP and add it to here. But what if this element which takes the DP of this and this is going to have the same as this? Okay, I think this is too clumsy, so I'll just change the color. So what if this and this are the same thing? So that will be a problem. So in that case, you may say that, bro, I'll do one thing, I'll just eliminate this, and I'll just check for all the other elements. But what if you're checking for all the other elements, but the best approach lied in the fact that, I think I'm short of colors. So the best approach lies in the fact that you considered this, and this specific element considered the position at this position, okay. So in that case, you're going to have a kind of anomaly, okay, a kind of ambiguity. So do you get it? Why I tell you that not to use DP, but you can use this. how you can for every specific element you have to store the frequency map. In that case, if you do that, then DP is perfectly fine. So if you're storing the frequency map for every specific element, then DP is perfectly fine. But I feel that DP is going to give you a memory limit exceeded error. Okay, I have not tried it. So is it clear, Soumya? So there are 3 people watching this right now. So Soumya, is it clear? I think I'm not lagging anyhow. Is it clear, Soumya? Yeah, it's perfect. My voice is perfect. Everything combination can crack frequency. Yeah, but again, if you're considering everything combination, in that case, as I was telling you, that there are 10 to the power 10 combinations possible, right, at maximum. So that is going to give you a TLE. Okay, so either you have to face a TLE or you have to face a MLE, memory limit exceeded. Okay. Actually, this question I'll just check the editorial, because I feel that my solution is not perfectly, like, it's too awkward. Okay, so I'll just check the editorial also. Don't need to worry about that. Okay, so just let me do one thing. I'll just check the editorial for this question. I don't know how to check the editorial. I think discuss, I guess. No, page not found. Okay, so what if I just remove this 413? I remove this contest. Now the discuss is there. Okay, so this guy used a recursion plus memoization. Actually, I tried memoization. Okay, so there is a DP solution. Okay, Soumya, I think you were right. So he's using bit mask. Yeah, you can use bit mask. That will, like, yeah, that's the thing. That's the thing. You can do that. You can do it. Okay, I was wrong. Like, yeah, you can use DP and use a bit mask instead of using the frequency thing. You are using a bit mask, so that basically what he does is he's also removing that the fact that, what to say, he's also removing the fact that you have to use a frequency array. So for that he's using a bit mask. Backtracking solution big O n factorial. But what I think is big O n factorial, I thought that big O n factorial is going to give me a TLE. Okay, so that was what I thought. Okay, I will try a DP approach for this. Can you tell greedy? Yeah, the greedy approach I'll be telling you. Okay, the greedy approach. Let me tell you first. These I think you can check. So I just go for the recursion. Okay, because I was also performing a similar kind of thing. So what he does is, for value in grade, he stores the row number, and for, like, okay, yeah, this is similar to the approach that I'm going to tell you for the greedy approach. Okay, this is quite similar. I guess this is quite similar. If I'm, like, till now what I got. Oh no, he's also used mask. Okay. If you're kind of weak using mask, so I'll just give you this approach. So this is the approach, like, this mask thing is already there in the, like, many people have explained that. I'll just go with the greedy approach. I'll just go with the greedy approach. I'll just keep it red and keep this black. So okay, so let's say you have I forgot to choose the brush. So let's say you have this grid. Okay, the grid looks somewhat like this. Ignore my drawing because my drawing is not that good. So what you can do is, for every specific element, you can just have a 1D array of size m into n, and for every specific element what you can do is you can just store the values. Okay, just store the values And along with that, what you can do is you can pair it up. Okay, you can use a pair. Okay. And in this pair, what you're going to do, first of all, you're going to have the value, and in the next place, you're going to have the row which contains that value. Clear? Now, if we sort it in a descending order, this whole thing, this whole pair array. So if we take the last, if we take greedily, if we take the last m elements, okay, m is the number of rows for now. If we take the last m elements and check for any element, for any specific element, okay, any specific element, if that element is in this whole thing. I got a lag on my side. Get it. M elements. Okay, M is. Now I think it's okay. So basically, okay. So basically, what happens is, where was I? So just check the microphone. Okay, it is connected. Camera is connected. It's perfect. So yeah. So for every specific element, if it happens that it occurred before that, or the row that is over there, it has occurred before that. So it is always a greedy approach. In spite of using this element, you go on traversing for the next elements. Okay, since you know that the maximum the maximum value that the maximum size of this array is 10 into 10, that is 100. So obviously you can go on traversing throughout all the elements. So 100 into 100 is a very good approach. Okay, so what you can do is you can just go on till here. Okay, till you get an element which satisfies that it is not over here, as well as the row is not there. So you are going to shift this position to that position. Then for the very next element, you are going to do the same thing. And then for the very next element, you are going to do the same thing also. And after you're done with this, you get the first element. Okay, for the first element also you can do the checking, but for the first element it won't be needed, because by default it will be unique. Okay, because it can be proven that the first element, which is the maximum element of the whole array, it will be always greater. It will be always, it will be always included in whatever the solution you are having. Okay, so in spite of doing this, you could have also done like getting the maximum element from every row, and then you are going to traverse till you get the second maximum element, and just do consider the maximum of all the second maximum, and then consider the maximum of the third maximum if there is a tie again, consider the maximum of the fourth maximum. So you do this until you get a tie. Until you get a tie, you just do it, you just continue doing it. So that's it. Okay, so you can do this. So this is the greedy approach. But I have the code, I have the accepted code, but I'll just post it. I'll just post it in the Discuss, and then I'll just give you in the link. But I feel somehow the approach that this guy has done, that is recursion plus memoization using bit mask, this is a better approach. Okay, so I'll just explain you the approach that this guy has done. What he has done is he's storing this integer dp. So I'll just give you the dp approach. So let's say public in maximum score, which is the given function that you have to perform. So he's taking the array and making it a new array list. Okay, and he's taking a dp, and this dp is going to have a bit mask of 101, that is a frequency thing. Okay, similar to the frequency thing. And what he does is this grid size. So you know that this grid size, it basically means that he's just storing for every specific value is binary stuff. Okay, he's just considering binary stuff, because for bit masking, binary stuff is actually needed. Okay, so now for 0 to 100, I think from 1 to 100 would have worked, but I don't know. Okay, I think from 1 to 100 also would have worked. So let me do one thing. Let me just copy this thing. Okay, let me just copy this thing, and I'll just submit this from my end. Okay, I'll just submit it from my end and check, like, because before telling anything I can't assure you, like, before. So I think if you consider from 1 to 100 it would work, but still, so let's submit it. Okay, so there is an error. Oh, okay, I did it for C++, sorry. I'll just do it for Java. I think I was trying with the Java also. So I think if he goes from 1 to 100 it also works, because he's just dealing with the frequency thing. Okay, so let me submit it. It does 100 out of bounds for this. Okay, so he was using this 0 to 100, I think, because for checking the index out of bound thing. Okay, I just think, yeah. Okay, so yeah, 1 to 100 won't work. Okay, so 1 to 100 won't work. So that's the reason why I tell you that it's always better to go for the go for the code and check why the person has done this. Okay, so for 0 to 100, what he does is he is going to add this to the integer list. Okay, he's adding a new integer list to it, and for every value in the grid he's storing the row number to it. Okay, so what he does is get num, and he adds just the row number to it. Okay, and then he searches from 100 to 1 to get the sum. Okay, so return get score 100, 0. So let's say the mask initially it is 0 because it is initially containing no element. Okay, now if the current item is 100, so if the current item is 100, what you can do is, if the current item is lesser than equal to 0, you can return 0, because current item will never be lesser than equal to 0, because it ranges from a size of 1, I guess, 1 to 100, I guess, if I'm not wrong. Yeah, it ranges from a size of 1 to 100. So he's just putting the base case as lesser than equal to 0, because remember one thing, he's using bit masking. Okay, so since he's using bit masking, he's just getting from 100 to 1, and once he reaches 0, he knows that this is the base case and he has to just break it, and he's checking that if dp of the current item, okay, current item and mask, if it is not equal to null, then you can return that. Okay, and if it is not so, what you can do is you can search for value less than, or I think for my video, I think if I'm getting the video, I think you won't be able to see it. Okay, so I'll just put it down and I'll explain you, and then I'll just come back to the video. Okay, so what he does is he's getting the score and current item -1 and mask. Okay, so basically he's just getting 1 by 1 lower. Okay, since he was traversing from 100 to 1, so current item -1 and the mask remains the same. Okay, the mask remains the same because he has already, like, this part is a kind of, you can say it's a kind of memoization. Okay, this is the memoization part. So what he does is basically what I was explaining you. So in spite of using that frequency thing, he uses a mask, which is a better approach, because in that case he can just consider from 100 to 1. Okay, for the frequency it will be like considering for every specific element 100, and that will be making it much more like memory limit exceed. Okay, and then for every row what he does is he's masking it. Okay, he's masking that with 2 to the power row. Okay, and then he's continuing it like this is only if masking this is going to get him a value greater than 0. That is, if the mask and this, and like there is no specific element where there is 0 and 1. I mean, where it is 1 and 1. Okay, if there is 0 and 0, it's good. I mean, it's you can't use it. If it's 0 and 1, you can't use it. If it's 1 and 0, you can't use it. But you can only use it if there is a 1 and 1 at every specific position. Okay. And after that, he's like, this is the normal thing that I was also doing. That is maximize score, current item plus get score of current item -1, and he's masking this with this by using OR. Okay, so basically this he was just checking whether like there is a 1-1 pair or not. If there is a 1-1 pair, he can continue it because he won't need to consider that. If it's not so, he has to mask it down. Okay, then only he has to mask it down, because that means that you have to consider that. Okay, and then he returns dp of current item and mask, which is equal to score. Okay, so basically he does this. I think it's a little bit complex, but if you can rewind the whole video and check it, so you'll get it. Okay, so whoever was watching this video, just give me a confirmation that you got it or not. Okay, just give me a confirmation. Whoever is watching this video, just give me a confirmation if you got it or not. So if you got it, I'll go into the last question. Okay. I will also check the editorial for the last question. Till then, you guys can tell me whether you got it or not. Just tell me if you guys have got it or not. We'll need to write in to understand. Yeah, that is exactly what I was telling you, that if you don't write on it, so it will be like kind of difficult for you to understand that. You can move to D. Yeah, I'll move to D. I'll do that. Okay. So before moving to D, I'll just check the editorial. Okay, I'll just check the editorial. Easier than it looks, intuition and logic. We see that if this is, we can solve for all pairs I, j separately and then use them in queries. Now we solve for given this thing. If we do it repeatedly, it is st of end I and st plus 1 of end. Yeah, exactly. This is what I was talking about. Okay, so he did exactly what I did. Yeah, actually I think this is the best approach. Okay, this is the best approach. So base case is dp of I is nums I. Okay, he uses dp for that. Creating the dp. So I'll just go with the code first. Okay, what he does is, over here he's taking the this is nums of size and he's taking a dp. Okay, now if you like this part, I'll just explain you first, then only I'll go to this solution. He did a solution similar to me, so I think like if I show you my code, it's too complex for you to understand, because during my contest I don't focus on writing a very like clear to understand code. Okay, so I'll just show his code, and he is in a very similar approach to mine. So it was given that for every element, for every specific element in this array, so what this element becomes is that for every specific element, the previous element is XORed to the previous element is XORed with the the present element is XORed with the next element, and we remove the next element. That is what we do. Okay, so if we go on considering from, let's say you have got A, B, C, D, E, F, G. Now for the first case, what you do is you have to remove this G. Okay, and this F gets added to G, E gets added to F, D gets added to E, C gets added to D. When I'm talking about adding, I mean XORed. Okay, B gets XORed to C and A gets XORed to B. Now, hello people. नहीं भाई, नहीं पहचाना भाई, सॉरी ब्रो. नहीं मजाक कर रहा हूँ भाई, पहचानता हूँ भाई तुमको. मनन, तुम कैसे हो बताओ. वैसे नाम तो अब पीटर नहीं है, अब नाम तो अब रिवील कर चुका हो भाई, नाम भी रिवील कर चुका, फेस भी रिवील कर चुका हो, तो नाम से बुला सकते हो, तो प्रॉब्लम नहीं है. सो फॉर दिस व्हाट यू डू इज, देयर इज अ जी ओवर हियर. नाउ इन द नेक्स्ट केस व्हाट वी डू इज वी आर रिमूविंग दिस, and this becomes EFG. EFFG, right? EFFG. But this F and F cancels out. Okay, this F and F cancels out. So if F and F gets cancelled out, what we can say is this F, this specific F, this gets replaced with G. But it was EF. Now over here it is replaced with F. Okay. this it is replaced with, instead of D it is going to be E. This is going to be D, and this is going to be C. So I hope this is clear right now, right? So what it is becoming, it is becoming E, G, D, F, C, E, B, D, A, C. Now again, if we are going to remove this, so over here it is going to be D, E, F, G. Okay, this is going to be D, E, F, G. For this, it is going to be C, D, E, F. Okay, so that is the next four elements. Now again, when we are going to perform this, now if we are going to delete this, so you can see that D, E, F and D, E, F are common over here, so it is going to be C, G, right? So there is a pattern, if you notice. Okay, there is a pattern, if you notice carefully, that everything after you are performing the operations, it is getting back to either two elements or four elements. I mean, either two elements or the elements apart from the two elements. Okay. So basically, this is a combinational thing. Okay. It's either D, E, F, G or it's D, G. It's either C, D, E, F or it's C, G. Okay. So it's like that. And if you go back to the last element, you can see one thing, that let's say you're considering A. So first A was XORed with B. It became A XOR B. Then it was XORed with BD. Okay. Then it was XORed with it was XORed with BC. Okay, it was XORed with BC. Then BD, and so on. So there is a pattern, if you notice. So this is what exactly he has done in his code. That is this pattern he has done. He has told us earlier that since it is given that A of I is XOR of this for every element, and we do it repeatedly, we can see that the relation it has is nums of ST end basic num of ST n minus 1 XORed with nums ST plus 1 to end. Right? Now if we are going to consider all the elements and XOR it and XOR it, for the first condition you are going to remove the first element, and for the next condition you are going to remove the last element. Okay, and you have to go to XOR that so that you can get a relation. This is what the relation looks like. Now this is, you have to think about this like what do you say, like a mathematical induction process. Okay, a mathematical induction process, what we do is, or we can say, we can deal it like a divide and conquer thing. Okay, so divide and conquer, it means that if you're going to add, like if you're going to make nums, okay, if you're going to have nums of I and j, okay, of I and j, okay, no, this is also considered. So you have to make XOR, the XOR has to be nums of I and j minus 1. Okay, and this will be nums of I minus 1 and j. Is this clear? Is this clear? Just tell me. And j. Is this clear? So I'm lagging back again, I guess. Yeah, but okay, so I'll just go to the next part. Okay, I mean, just I'll just explain that part. So over here I can see that my quality is getting, no, now it's okay, it's 3410 kbps, and drop frame is also 2.4%. So technically it is like I'm getting a better, the video quality is better right now. Sorry, but मैं तो बीच में आया, so what else you can basically go to the वापस, हाँ exactly वही बोल रहा था मैं. 3410 kbps. So it may happen that a little bit, it's lagging a lot. It's 14 kbps. It's lagging a lot. What I can do is like I can change the thing. Optimum is also 2.4%. Exactly. The lagging increased. Fix it. Do one this. Let me just remove the video first. कम कर सकते हो instead of live make videos of whole contest and then upload. Yeah, I can do that. Okay, I can do that. That's not a big deal. But what I feel is that वीडियो बनाने के बाद एडिट करने में बहुत टाइम चला जाता है, ठीक है, तो इसलिए आई प्रेफर कि जस्ट गो फॉर दिस वीडियो थिंग. So I hope the lag is fixed right now. Okay, so I'm just assuming the lag is fixed. So just people just tell me if the lag is fixed or not. Okay, because I think from my end the lag is fixed. Okay, so chalo, let's get in the video. So I think this is clear, right? This part, like whatever I was explaining, this thing. So I think Somis told me that it is clear for him. So I'm just assuming that it's clear for you guys also, whoever will be watching this video at a later point. So after that, he has done that for range. So there is a base case. Okay, now there are base cases also. The base case is dp of I and I is going to be dp of is going to be nums of I. Okay, because if you're going to consider just one element, so you know that that one element, if XORed, it is going to be that one element only. So this is the base case. Okay, and then for range of st to end, what you can do is you can make dp of st and end as dp of st end and st plus of end, which I was telling you guys. Okay, so basically if you're getting the dp whole thing, this dp thing, by just XORing the all the like XOR of this thing and XOR of this thing, I mean, okay, like I know you guys can't see me actually. So the XOR of upload like Anubhav Avasthi, lag is fixed. Anubhav Avasthi kaun hai bhai? I don't know. So basically if you're going to do the dp of this and dp of this, okay, so if you do this, so it will be like you'll get it. Okay, I hope that's clear. So now let's get into the more part of the video. I mean the rest part of the code. So he says that we are using the subarrays only to create dp. But this is not, we need the maximum value. Let us consider all the values. Exactly. There's again a lag. There's again a lag. I don't know what the heck is wrong with this. See, it's showing me 4485, 4102. Okay, the whole, like the kbps, the kilobyte per second, the bit rate is perfect, but I don't know how it's lagging. Okay, I think there must be an update from OBS. Okay, that is the reason of the lag, I guess. So, anyways, Zeta, like I don't get it. ऐसा तो नहीं है ना तू मुझे डिस कर रहा है भाई? कोई डिस विस तो नहीं करना ना? Anuvav Avasti from Zeta. I'll check the video. Okay. Anyways, so what is over here is that this is what I was telling you this. So let me go back to the code. So for this you can say that the time complexity big O n squared, because for every specific element you are going to consider I and j, and I mean for every specific subarray, and the space complexity is big O n squared because you're using dp and dp of n into n size. Okay, dp of n into n size. Now for every dp what he does is I'll like he initializes dp of I and I as nums I, and for the remaining part he does this thing dp of st of n is equal to dp of st n minus 1, dp of st plus 1 n. Okay, so basically what he does is he knows that if you are getting the dp of two specific ranges, so you can find the dp of another specific range based on that. So basically he does this, then he does this also. Okay, he does the same thing, that is you're going to maximize. Okay, if it is like for the first time you can just keep the dp like this, but for the next time what he does is he is just checking for the same thing, the similar approach he does, but for now he is going to maximize. That is, let's say after you operated on the dp, okay, now there is a change in a few elements of the dp. For that specific changes you also have to change the element which has occurred, like which has like let's say let me like show you using this. So let's say there was a dp, okay, this was a dp and this specific element, so let's say this was a dp array, dp2d array, and this specific element dependent on this and this element. Okay, since it was said that it is depending on two elements, so this specific element is dependent on this and this element, this element and this element. So after doing the whole modification, this element gets modified and this element gets modified too. Now what if now the present the present modification will also modify this, but from one point of view we can say that let's say we operated this at the beginning, so after we modified this, these and this and this modified, so we have to again modify it back to over here to maximize it. Okay, so that is what he has done over here for this part. Okay, the reason he's using this loop, this whole thing again. Okay, and then he's just googled and every query he's just returning dp of u comma v, I mean u and v. So this is a very simple. Okay, this is simple. I think this I'll just upvote this. Okay, I'll just upvote this. This is a very good approach. Who has done it? Anuj Jadhav. Okay, this guy, that's damn man. This is way better than my approach. So I hope this D is also clear with you guys. Just tell me if it's clear. Yeah, I can. अच्छा ये बता रहा हूँ तुमको, ठीक है? I can upload a whole video. I can record a whole video and then upload for the whole contest. But I feel that it won't be interactive. Okay, when I'm live, I think it's interactive. Like if I may like go through a part of a question which people won't understand, and they will be thinking that okay, this works like that, this works like that, but they won't be clear much about the topic. Okay, so that's the reason I do it. So anyways, I think I'll just end this video because I've explained all the 4 questions. I'll just end this video. So before ending this video, let me tell you that initially this channel used to be by the name of Peter Green Codes, but now it's by my name, Georgie Codes, and so consequently my reach is not that good at this moment. So it will be better if you guys can like share with your friends, you can like the video and subscribe my channel if you haven't subscribed yet, and just comment down okay some feel about this video and just do it. Okay, so that will be great from your side and from my side also. So that's it from my side. I'll just end this video. Thank you. Somewhat clear. Okay, somewhat clear. I think it will be clear if you like get into the, if you just code it down. Okay, the D was easier. Okay, D was easier than C. So if C is clear for you, D will be also clear for you, because as I was telling you that this pattern thing, okay, this pattern thing, this pattern you have to understand very carefully. This pattern thing. Okay? There's a specific pattern. Now if you get the pattern, you can say what is the DP of this, and if you know the DP of this, so you can get the DP of this. Okay, this is what the pattern thing is all about. That's the DP thing. Okay, so that's it from my side. I'll just check Discord. I have an idea for you. Okay, let's check it. I'll just check it after this.